Hey, this is part 2 of finding domain and range of functions 3.2. And we're picking up with example 2. We just talked about how to write inequalities in interval notation. And so when we do domain and range of equations, we often have to write them in interval notation. So let's go back up and talk about how to actually find the domain and range, because we talked about what interval notation was, but we didn't actually talk about how we would use it in the case of domain and range. So what we do is we identify the input values. So we think about what are the values that we are able to input into a specific equation. So there are some equations or functions where there are some numbers that get excluded from the domain, such as square roots. So numbers under the square root sign cannot be negative. You can't take the square root of a negative number or it will be an imaginary number. So in that case, negative numbers, if it were the square root of x, negative numbers would not be included in the domain. If it was a square root of something where it was an expression, not just the x, but an expression such as 2x plus 4. Well, that expression can't be a negative number, so you would set up an inequality to figure out what numbers would cause it to be negative, or what numbers would cause it to only be a value that can have a square root and not be an imaginary number. The point is, we identify those input values and which values cannot be inputted. And then once we do that, we identify any restrictions on the input and exclude those values. So that's just kind of what I was talking about. In the case of the square root of x, we would exclude all negative values because you can't take the square root of a negative number. And then you would write your domain in interval form if possible. So let's go to example 2. It says, find the domain of the function x squared minus 1. So what you need to do is you need to think to yourself, is there any number that can't be an input for x? Is there any real number that cannot be an input for x? So is there anything that if you put it in for x and then squared it and then subtracted 1, is there any number that would give you an undefined answer, or something like the square root of a negative number where you can't find that? And so I can't think of anything at all. X squared minus 1 is a quadratic. That's it comes from one of our parent functions, the quadratic, because the quadratic has the squared. And so since there's nothing that we can think of that if we put any number, any real number from negative infinity to positive infinity, any real number, if we put that into this expression, x squared minus 1, you're going to get an answer. So in this case, the domain can be any number from negative infinity to positive infinity. It can be the whole number line. So you can just write your domain just like that. Just like that. And so then I just want to show you, you can also write it like this. R with like an extra bar, that stands for all real numbers. You can also write it like this in inequality notation, where we can say that x is all numbers between negative infinity and positive infinity. And a lot of times you might see it in set builder notation, which we may talk about in a little bit. All right, so you guys try the triad, number 2. Find the domain of the function f of x equals f minus x plus x to the third. So what I need you to do as you're trying this is ask yourself, are there any numbers that if you were to plug them in for x would give you an unreal answer? Is there anything that you would need to exclude from the domain? And then if there is, write that out in interval notation. Write the numbers that can be included in interval notation. And if they can all be included, then you would do the negative infinity to positive infinity, just like we did here. Okay, so pause the video, and when you come back, we'll go over the answer. Okay, so x to the third, you can put any number in, any real number in, and cube it. You can put any number in as an x and subtract it from the cube and add it to the 5. So this would also be all real numbers. Interval notation would look like this. Negative infinity to positive infinity with parentheses because it can't equal either of those infinities. Or, oops, in inequality notation like that. Okay. So, how to, given a function written in an equation form that includes a fraction, find the domain. So again, identify the input values, identify any restrictions. So here is the thing with fractions. Okay. If there is a denominator in the function's formula, that denominator can't equal 0 because you can't divide by 0. So if what is on the bottom of a fraction equals 0, then you get an undefined answer. So if the formula contains an even root, set the radicand greater than or equal to 0 and then solve. So that's something separate. So if you've got a denominator, if you're trying to figure out the restrictions, you set the denominator equal to 0, and that will tell you what you can't put into the equation in the domain. And if you have an even root, like a square root or a fourth root, you set what's inside, the radicand, greater than or equal to 0, and then solve. And the reason you want to do that is because if you've got an even root, like a square root, what's inside it can't be negative. So it has to be greater than or equal to 0. It has to be positive. So you can set it greater than or equal to 0 and then solve that inequality, and that's going to tell you what your domain can include. And then again, write your domain in interval form, making sure to exclude any restricted values from the domain. Alright, so we have the function x plus 1 over 2 minus x. So this is a fraction. And we are not solving this function. We're not evaluating the function. We are finding the domain. So what we're doing is we're trying to figure out what numbers we are allowed to input for x. What would the domain be? Domain are all the possible input values. And normally if it were ordered pairs, we would list them. But in this case, a lot of times there's an infinite number of values that you could input for x. But let's see. If we had x plus 1 over 2 minus x, this denominator, that can't equal 0. Because if that equals 0, then the whole function will be undefined. So what we do to find the domain is we set that equal to 0, or I like to go ahead and set it not equal to 0, and solve. So we would subtract 2 from both sides, and we get negative x isn't equal to negative 2, and then get rid of that negative by dividing by negative 1, and so x can't equal positive 2. So let's look at what that looks like on the number line to kind of help us with this interval notation. So here's 2. All right, you have all these other numbers on the number line. It can't equal 2, but it can equal all the numbers to the right of 2 and it can equal all the numbers to the left of 2. It just can't equal 2 in the middle. So it's all these numbers here and all those numbers there. It just doesn't include 2. So all these numbers on the left, that's from negative infinity up to 2. And again, it can't include 2, so we use parentheses. And then the one on the right, that's all the numbers from 2 to infinity. And again, it can't include 2. And then, as I told you earlier, if you've got 2 intervals, we connect them together with a union symbol. So this shows that the domain is all real numbers except for 2. All right, your turn. You guys do try it. Number 3, find the domain of the function 1 plus 4x over 2x minus 1, remembering that this is a fraction function. So go ahead and hit pause, and when you come back, we'll go over the answer. Okay, because this is a rational function, we know that the denominator, which is 2x minus 1, cannot equal 0. So if we solve this for x, we would add 1 to both sides. We're left with 2x can't equal 1. And then we divide both sides by 2. In this case, x can't equal 1/2. And so just to clarify what's happening here is, if I were to substitute 1/2 into this denominator, it doesn't matter what happens in the numerator, because what happens in the denominator is you get 0 if x is 1/2. And if you get 0, it's undefined. So what that means is I can't substitute in 1/2. So that means that x is all numbers except for 1/2. So it's all the numbers from negative infinity to 1/2, not including 1/2, union with all the numbers from 1/2 to infinity. All right, so now we're going to do the roots, and I know I kind of mentioned how to do that before, a little bit in the other one, but they put it here too. So again, you're going to identify the input values. Since it's an even number, an even root, that means that the radicand has to be positive or 0. So whatever's on the inside here, that has to be a positive number. So what that means is, it means that 7 minus x has to be greater than or equal to 0. If it's a number less than 0, then you're going to get an imaginary number, and we want a real number. So our domain are the numbers that are going to be inputted for x that will yield a real number for the output. So if we're trying to say 7 minus x has to be greater than or equal to 0, then let's go ahead and solve that inequality. So we have negative x, and we want to get it by itself, so we're going to subtract 7 on both sides, and we get negative x is greater than or equal to negative 7. Now, I'm not sure if you remember, but the rule for inequality solving goes, when you divide both sides by a negative, you have to flip the inequality sign. So I need to get rid of this negative in front of the x, and that's really a negative 1. So I divide by negative 1. What I do to one side, I do to the other. And what happens is, when I divide both sides by a negative, it flips it and makes it less than or equal to instead. So the negatives cancel on the left and leave x. And negative 7 divided by negative 1 is positive 7. So x is all real numbers that are less than or equal to 7. So here's 7. It can include 7. All numbers that are less than or equal to 7 would be all numbers to the left. So it's going to be all numbers from negative infinity all the way to 7. And you can't include negative infinity, but in this case it looks like it does include 7, so we would use a bracket for that. So that would be, again, the domain. So what this means is you can only substitute in numbers into the x of this function that are between negative infinity and 7. Okay, so you guys try this one. Find the domain of the function f of x equals square root of 5 plus 2x, and unpause when you're ready for the answer. Okay, so in this case, the radicand 5 plus 2x has to be a positive number or 0, so it has to be greater than or equal to 0. So we're going to solve this by subtracting both sides by 5, and we get 2x is greater than or equal to positive 5. Divide both sides by 2. We know that x is all real numbers that are greater than or equal to 5 halves, or we could say greater than or equal to 2.5. So let's say 5 halves is right here. The graph has an equal sign, so it does include 5 halves, and then it's all the numbers that are greater, so all the numbers to the right. So in interval notation, my lowest number is 5 halves, my highest number is infinity. It can equal 5 halves. It has to include, it cannot include the number infinity exactly because, again, infinity is an idea, so we use parentheses for that one. Alright, so we're going to stop the video here. That way you guys can take a break, come back later, and we'll start part 3 at this point when you're ready to return.